Good morning everyone. So welcome to the second week. Today we are discussing with the criterion A problems. So this problem is on collisions. So what are the types of collisions? So 2 marks. You can mention what are types of collision. You have an elastic collision, elastic and inelastic collision. And the elastic collision is one wherein momentum and energy is conserved, or maybe you can now write energy is not lost. And here you can say energy lost in the form of heat, sound, light, etc. Okay. This is what you call the inelastic collision. Let us go to the next one. Image below shows a bullet fired on a block. Using the above diagram, one state the type of collision and its reason. Now, what's happening over here? The bullet is fired from it and it hits the block, and the block actually starts moving and the bullet is simply embedded inside the block. Okay, so therefore now you need to mention what kind of collision is this. So when this one hits, is for how many marks? Is for 1 mark. So when this hits over here, so this is an inelastic collision. Now, why is it an inelastic collision? So you get the energy is lost. Energy is lost because it has to bind to this one here, right? So there is an adhesive force between the block and the bullet, and the bullet does some work to stick or embed in the block. That is the first thing that happens. Okay. And secondly, what happens over here? When the bullet hits the block, a sound is heard. And hence energy is lost. Okay. Both the reasons you can mention to say that it's an inelastic collision and what is the reason. And hence energy is lost, and as a result of it is an inelastic collision. Next. A car of 1000 kg mass is given, is moving at a velocity of 20 meters per second. Initial velocity is given. With hits a stationary car of mass 800 kg. So this is your mass m1, your mass m2. The two cars move together after collision. Find the momentum of the system before collision. So what is it? Let us write down the diagram. This is your mass m1, 1000 kg. Now this moves at the speed of 20 meters per second. You have another mass m2, which is 800 kg, which is stationary, and after hitting both m1 and m2, they start moving, and he is asking you what is the momentum of the collision system before collision. So how do we write it? In any type of collision, whether it is an elastic or inelastic, momentum is seen to be conserved. But anyway, he has not gone even until that level. He is only asking you what is the momentum of system before collision. Momentum of the system before collision is momentum of this plus momentum of this, right? So momentum of this would be 1000 multiplied by 20, mass into velocity, plus what is the momentum of this? This is 800 multiplied by what is the velocity of this? 0, because it's not moving, it's at rest, right? Stationary car. So it should now be equal to 2 multiplied by 1, 2, 3, 1, 10 to the power of 4. Unit is kg meter per second. Okay. Next, find the velocity of the cars after collision. What is the velocity after collision? So therefore, now here, how do I write? Using conservation of momentum. How do I use conservation of momentum here? I can now say momentum before collision. What is momentum before collision? This is before collision is 2 into 10 to the power of 4 is equal to momentum after collision. What is momentum after collision? See, both the blocks have joined together and is still moving. So therefore, total mass here is 1000 plus 800 multiplied by it moves the velocity v. So which implies v is equal to 2 into 10 to the power of 4 divided by 1800. So what is the answer for this? I calculate once again. It should be 2 into 10 power 4 divided by 1800 will be so much. This one would be multiplied by 1, 2, 4, 10,000. Would be 11.1 meter per second. This is the answer for this. Okay, thus here you get 2 marks and here you get 2 marks. Next question. With reference to the above ball, ball 1 has a mass of 1 kg and has an head-on collision with the ball 2 of mass 2 kg. Okay, so ball 1 has a mass of 1 kg and this has a head-on collision with ball 2 of mass 2 kg. Kg here, 1 kg here. Ball 1 has an initial velocity of 2 meter per second. Meter per second. This is 3 meter per second. Ball 1 has a velocity of 1.5 meter per second after collision. 1.5 meter per second after collision. Oh my god, so many values are given. Find the initial momentum of the system. What is the initial momentum of the system? Okay, it's not asking you for one ball. System will now be, this whole thing is one system. Okay, whole thing is one system. So what should I do? I should write 1 into 2, 1 into 2 plus 2 into this minus 3. Okay, not plus 3 because you know velocity is a vector, momentum is a vector, so it's minus 2. Minus 3 should now be equal to 2 minus 6 should be minus 4 kg meter per second. Units are very important, only then you get the full mark. This is initial momentum before the collision, okay, of the full system. Then final momentum of the ball 2 after collision. These are your final momentum of the ball after collision. You see, already it's given that the momentum of this ball, velocity of this ball is 1.5 and the mass is 1. What is the momentum of this one? Momentum of this one is in this direction, which is negative, which should be minus 1.5 kg meter per second. It's already known to you. Now what we do is, let us say this momentum is P2, I do not know. What does conservation of momentum tells you? It tells you momentum before collision is equal to momentum after collision, which means what? Total momentum before collision equal to total momentum after collision, right? What is total momentum before collision? Minus 4, minus 4. What is total momentum after collision? It should be minus 1.5 plus P2. This is known to you now. Okay, so therefore now what happens? Now I'll write P2 is equal to minus 4 plus 1.5 should now be equal to minus 2.5 meter per second. Kg meter per second. Kg meter, which means this ball is also moving along right, in this direction because this mass is too high, right? So definitely it has to move in this direction. So I got the answer as minus 2.5 kg per second. Then anything else? Okay, that's it. Okay, so for today, so these are the set of problems. We'll see the new set of problems tomorrow on Criterion. Thank you.